Earth Systems 3209. Unit 4, the Forces Within Earth. References on this unit can be found in Chapters 4, 15, 16, and 19 in the textbook, and also in Appendix A and Appendix B of the Curriculum Guide. Unit 4, Topic 2.5. This topic will look at plate boundaries, namely the divergent boundary. The presentation will focus on describing a rift valley and explaining how it evolves into a divergent boundary, and also will focus on demonstrating through a drawing the process associated with plate divergence. When we look at plate boundaries, according to the plate tectonic theory, three boundaries exist at the edges of tectonic plates. These boundaries include a divergent boundary, which is also called a ridge, a convergent boundary, which is referred to as a trench or subduction zone, and a transform boundary. Information on these three boundaries can be found in your textbook on pages 526 to 539, and also you should make reference to figure 1917 on page 528, where you can see the actual boundaries in a figure. Let's take a closer look at divergent plate boundaries. A divergent plate boundary is characterized by two plates moving away from one another as a result of tensional forces exerted on them by convection currents in the upper mantle, called the asthenosphere. As the plates move apart, hot molten material upwells at the boundary, forcing the edges of both plates to move upwards, and this creates a geologic feature called a ridge. So ridges are located at divergent boundaries. At this type of boundary, new ocean floor is being created along the length of the ridge as the two plates move apart, which is caused by tensional forces from convection currents. The divergent plate boundaries are referred to as constructive margins, since ocean crust is being formed there. Examples include the Mid-Atlantic Ridge and the Mid-Indian Ridge. If you look at the diagram below, we notice that we have continental crust on both edges. Connected to the continental crust, we have ocean crust. And in the middle, we have magma that's upwelling from deep down below. So the upwelling of magma will cause a feature called a ridge in the middle, and on both sides of the ridge, the ocean floor moves in opposite directions by tensional forces, which are indicated by the blue arrows. So tensional forces caused by the movement of convection in the asthenosphere will cause the ocean plates to actually diverge, that is, move away from one another, and it creates a geologic feature called a ridge in between. These divergent boundaries are seen at the Mid-Atlantic Ridge and also the Mid-Indian Ridge, and it causes continents to move farther and farther apart. Let's look at the evolution of a rift valley into a divergent plate boundary. When a rift valley forms, it generally forms if tensional forces due to the motion of convection currents in the upper mantle begin beneath continents. It can cause continents to split into two or more smaller segments. In the diagram below, we see that we have a concentration of heat beneath the continent, and as this heat moves upwards, it tends to rift, that means split, the overlying continent, so it can move outward in two different directions. So we see a weak area developing in the continental crust, and the magma forces its way up through. This heat source will cause the rock to act as a plastic, and it can eventually crack and move off in different directions. Information on rift valleys can be seen in your textbook on page 532 and 533. As a spreading center is formed, and a rift valley is formed as a result of the associated faulting, which is normally normal faults, and the crust thins, eventually the thinning becomes significant enough for the ocean water to move into the rift valley. So as the continental crust starts to thin, and we start to see a lot of normal faulting occurring within this area, the actual tectonic plates, and in this case it'll be a continental plate, will start to move off in different directions, resulting in a large linear valley forming on the continent. This will eventually split apart and water can move in. The third stage in the formation of rift valleys states that once the ridge or rift volcanism and seafloor spreading begin, a divergent plate boundary is produced. So once the continent rifts and it splits off in two different directions, we see the two land masses now separating. We see that we have a lot of normal faulting occurring along the rift zone. And water moves in to form a sea in between the two land masses, which was previously one continental landmass. So one continental landmass splits to form two separate landmasses separated by a linear sea. And the final stage in the formation of a divergent boundary states as both continue, the land masses on both sides of the ridge continue to move apart from one another. And a present-day example where this is occurring in the world is the East African Rift Valley. Another such place where it occurred in the past would be when Africa separated from South America and Europe separated from North America. And this produced what we call the Mid-Atlantic Ridge in the middle of the Atlantic Ocean. So if we look at the diagram below, we see that the two continental land masses are now widely separated by a fully developed ocean, and in the middle of the ocean we still see the upwelling of magma along a ridge and the rifting still occurring at the ridge where it's separating by tensional forces, but it produces a full-fledged mid-oceanic ridge. Let's look at a sample problem. Using a labeled diagram, briefly describe what happens at a mid-oceanic ridge. So if we look at a mid-oceanic ridge, we see tensional forces that cause the plates to move apart, and this results in upwelling of molten material to form the mantle, from the mantle to create new ocean floor. So if we look at this in a drawing, we would first start out by drawing the ocean floor and have it move upwards, which represents a ridge. Down in the mantle we would have a magma source, and then you continue drawing the lower edge of the ocean floor. And notice that the ocean floor is thicker at the ridge because it's a high heat source, and heat would cause the salt material to expand, and also the influx of magma moving upwards would also cause the ridge to move upwards. And a mid-oceanic ridge is located beneath ocean water. So in this case, we have magma, and the magma tends to move in an upward direction. This upward direction and upward of the heat flow will cause currents called convection currents, which move up and outward. And this outward movement of the convection currents in the upper mantle, called the asthenosphere, would cause the oceanic plates to move away from one another. And this would be called, or caused by tensional forces. So in the middle we have a ridge, and we see the plates moving in opposite directions, which are caused by the convection currents in the mantle, and this is caused by tensional forces. So this would be a diagram that you could use, or one similar to this, to help you explain what actually occurs at a mid-oceanic ridge. When we compare the three different types of plate boundaries, first look at the type of boundary. We have three different types of plate boundaries that are located at the edges of tectonic plates. We can have divergent boundaries, which we are studying in this presentation, but we could also have a convergent boundary or a transform boundary. At each of the boundaries, we see different types of motion. The divergent boundary shows spreading of two oceanic plates, as demonstrated in the diagram below. This spreading creates new ocean floor, which is called constructive forces. The feature that is formed on the ocean floor would be called a ridge, and the process which forms the ridge would be called rifting. And we do see volcanic activity present at divergent boundaries. We also should note here that we do not see earthquake activity at this type of plate boundary. The second type of plate boundary is called a convergent plate boundary. At convergent plate boundaries, we see the motion which result in subduction. And what causes subduction is compressional forces where two plates move toward one another, as seen in the diagram down below. At convergent boundaries along subduction zones, we see destructive forces where oceanic lithosphere is being destroyed as one plate is subducted down into the mantle where it is melted. The feature that we see on the ocean floor would be called a trench. And we do see volcanic activity associated with this type of boundary. And we should note here that we also see earthquake activity associated with this type of boundary. And earthquakes can be close to the surface, which is called shallow focus earthquakes. A little deeper into the asthenosphere, called moderate focus earthquakes. And we see it deep into the mantle, which we call deep focus earthquakes. And the third type of boundary associated with plate tectonics is transform boundaries. In transform boundaries, we see the lateral slotting of one plate against another. And this is generally caused by shear forces. Along this type of boundary, we don't see any destruction or creation of new lithosphere, so therefore this boundary is called a conservative boundary. We don't see any major features on the ocean floor or on any tectonic plate, because transform boundaries can exist beneath the oceans and also within continents. And we don't see any volcanic activity associated with this boundary. But we should note that we do see earthquake activity associated with this boundary. And these earthquakes are generally close to the surface, so they're called shallow focus earthquakes. So this table would summarize the three effects or different geologic features and conditions that are associated with the three different types of plate boundaries, that being divergent plate boundary, convergent plate boundary, and transform plate boundary. And you should be able to contrast each of these three different types of plate boundaries. Let's look at some examples from past public exams. Example 1 reads, at which of the following is crust being created? So we know that we have three different types of boundaries, and the boundary in which crust is created will be a constructive boundary, and this would be the divergent boundary. An example of a feature at a divergent boundary would be the ridge. So at a ridge, we see crust being created. So the answer to the first question would be A. Second question reads, what rock type is generated at oceanic ridges? We know that oceanic ridges are located beneath the oceans. Therefore, they form in the ocean floor. And the main rock type that makes up the ocean floor will be a rock called basalt, which is a mafic rock. So our answer to the second question would be B, basalt. Basalt would be the rock type generated at oceanic ridges. Example number 2. First question reads, which plate boundary does tensional forces dominate, resulting in tectonic plates moving apart? So previously we studied that tectonic plates move apart due to tensional forces, Intentional forces are seen at divergent plate boundaries. So the answer to this question would be B, divergent plate boundary. Last question for example 2 reads, the rocks of the Avalon Peninsula in North America are similar. Which tectonic process was responsible for the separation of the Avalon from Africa? So associated with this question, we assume that when Pangea first existed, that Africa and the continental crust of North America, where Newfoundland, the Avalon Peninsula, is today, was actually joined. When they split apart, the land masses rifted. So rifting is a process that explains why the Avalon Peninsula and rocks in North America would be similar, because at one time they were in close proximity to one another. So the answer to this question would be C, rifting. Your turn. Take time and complete the following question. You can pause your recording now to prepare your answer, and the solution will follow. Question reads, which sequence correctly illustrates the evolution of a divergent plate boundary? So if we look at a divergent plate boundary, we need to look at the evolution from a continent to the continent splitting to a ridge system being formed, overlain by ocean water. So when we look at the diagrams to the right, we see in the first diagram, we see a lot of normal faults, and we see water present. In the second diagram, we see a lot of fracturing in the continental crust. Third diagram, we see the fracturing in the continental crust with a lot of rifting and normal faults, which creates a rift valley. And the fourth diagram would be just the continental crust without any effects on it. So if we look at the answer, our answer to this question will be D. First we start off with diagram 4, which is continental crust. The continental crust then starts to develop fractures and rifting. These rifts start to develop into normal faults, where we see a rift valley forming as the two plates start to move apart. And finally, diagram 1, the rift valley with some volcanism producing a rift valley which produces a ridge system in the middle and surrounded by ocean water. So our answer is D, diagram 4, followed by diagram 2, followed by diagram 3, and finally diagram 1. When we look at an overview of the points covered in this presentation, and a divergent boundary, which is one of the boundaries found at the edges of tectonic plates, divergent boundaries, we see plates moving apart, which result in the upwelling of molten material from the mantle to create new ocean floor. Therefore, we find new ocean floor being created at divergent boundaries, and at divergent boundaries, we see the plates moving apart. The feature that forms as a result would be called a ridge. So ridges form at divergent boundaries. We also see the plates moving apart, and this is caused by tensional forces, which would cause two oceanic plates or continental plates to move apart. We see new ocean floor or ocean crust being created as a result of the tensional forces. And these boundaries are referred to as constructive margins because they create new ocean floor. And global examples where we see divergent boundaries or rift valleys forming into a divergent boundary could be the Mid-Atlantic Ridge and the Mid-Oceanic Ridge. And a ridge zone that is currently producing normal faults which will eventually develop into a mid-oceanic boundary